Hey guys, welcome back. You are watching part 2 of the Bridgeport Millhead Overhaul project. It's so great to have you along. If you missed part 1, scroll down and I've attached the link if you'd like to catch up. Okay, now moving along through this process, the original goal was to reconnect the chain link that controls the variable speed tilt plate and also to change the motor bearings. During disassembly, I found a lot of wear in the pulley bushings as well as a couple additional bearings. This led me to order a top half refresh kit. Now, I could have simply stopped right there, but of course once my brain starts dwelling over a problem, I can't seem to shut it off until all my concerns are addressed. This is the first time I've ever been inside this unit. I've owned it for 20 plus years. It was supposedly refreshed just before I bought it. What I've witnessed in this head so far though is concerning. Since I've gone this far, it makes no sense to not refresh everything, whether it needs it or not. I'm talking every bearing, belt, bushing, grease, and even the brakes. I'm doing this because I don't want to have to tear this back apart in 3 years when an old bearing goes out just because I failed to replace it now. What we're about to get into here is the timing belt and bowl gear assembly. This rear timing belt pulley will come off with a couple pry bars or a gear puller will work. This is the top bearing hub for the small bowl gear. It should pop right out. This is where my camera decides to overheat and freak out on me. Unfortunately, this footage wasn't captured, but allow me to describe what's going on. This large bowl gear is removed by gently prying it up. The lower gear bearing hub will come up with it since it's all one piece. I'll shake this bottom side bearing out, but the top bearing will need to go to the off-camera press. There are two C-clips inside this bore, and it's not really necessary to remove them just for a bearing change, but I'm going to anyway since every component is getting a deep cleaning. I don't often comment on products I use. Sometimes though, if I feel a product works as advertised or even better, I feel it would be a disservice to my viewers to not mention it. I've used this CRC heavy duty degreaser throughout this entire overhaul, and there is nothing it couldn't handle. Okay, in this package we have the new Timken spindle bearing set. These are the timing belt pulley and bull gear drive bearings. We have a new set of brake pads and springs, a new timing belt, and another goodie we'll show in part 3. Here I already have the top bearing pressed in. I just need to install this spacer, the wavy washer, and then I'll press in this lower bearing off camera. We will want to make sure this nut is very tight. Many bad things will happen very quickly if this assembly comes apart during operation. Okay, now on to the small bull gear shaft assembly. Installation of these bearings is pretty straightforward. I'll send them to the press off camera. This is the old brake pad assembly. Disassembly is quick. We'll give this a good scrub down, grease the levered cam, and then install the new pads. Alright, let's move on and remove the spindle. Now it's important to remember to first remove this set screw, otherwise you'll end up damaging the threads on your end cap. Luckily I had a spanner wrench hiding in my toolbox that fits this end cap perfectly. I use a soft rubber mallet to drive out the spindle. With just a few taps and it comes right out. It's not entirely necessary to remove this collet key, but cleaning this spindle will be easier with it out. A good punch will bend back the locking tab on this washer, and another spanner wrench will be used to remove the nut. Do you see how that bearing spacer is shifting around? Well, it didn't start doing that just because I removed the preload when I loosened the nut. It was shifting around before that, meaning there was little to no preload on the bearing stack at all. Initially I was having second thoughts about even removing the spindle, but now I'm glad I did. It's important to note the direction of this long spacer. One end has a beveled end to match the inner race of the small bearing. This dust cap is damaged. Looks like I better order a replacement. Alright, well these parts are clean and are pretty hot, but so far looking good. The replacement dust cap has just arrived, so now we can proceed with this spindle reassembly. Okay, I have the dust cap and the first bearing pressed on. I'm wiping everything down with Chemtech lint-free wipes. I don't want so much as a speck of dust between the contact points. Now this may not be a clean room, but it's important to do my due diligence to keep these as clean as possible. These are sealed and matched bearings. The outside race of both bearings have a line printed on them to indicate the location of highest runout, though this amount of runout is quite small. Before applying a preload to the bearing stack, it is important to ensure the lines on both bearings match up and align as close as possible. By not paying attention to this detail, it is to invite eccentric deviations along the axis of rotation, increasing total indicated runout. Here I am applying a thin coat of extreme pressure lube to these bearings before reinstalling the spindle. It is important to not get heavy-handed with any part of this operation, because the moment you do is the moment you screw something up. Check your clearances and if there are any obstructions. The spindle should slide in almost effortlessly if you've done your part. Okay, well now we'll get this cap put back on and reinstall the set screw. It's important to note that over-tightening this cap is quite possible and entirely unnecessary. So if you over-tighten this cap, the spindle won't want to spin at all. You also don't want to over-tighten this set screw. By over-tightening the set screw, you risk deforming the quill, which will also create runout and make it more difficult to raise the quill up into the housing. Time to install this small back gear shaft. I want to make sure this bottom bearing won't become stuck in the hub next time this shaft is removed, so I'm applying a touch of lube here. And we're getting really close. It's now time to set this timing belt and pulley shaft. So last video I mentioned it's important to be sure not to twist the steel bushings when setting the epoxy for the plastic bushings on the pulley shaft, and here's why. I guess I was on autopilot at that moment and made the slightest twist which rotated one of the plastic bushings about 3/8 of an inch. This caused a misalignment of the keyways, and I didn't notice it at the time because there was a layer of epoxy covering this feature. Once I removed the steel bushings, I then realized that I messed up. So I had to order another bushing kit, even though I only needed to replace one bushing. I'll spare you the repetition of resetting this bushing. Remember this top pulley hub bearing? Well, now it's time to finally replace it. Man, that sounds so much better. Alright, let's get these pulley hubs put back onto the motor shaft. Just slide this clip on and it's ready to go. I almost forgot the fan blade and the top cover. Now finally we have the top cap bearing to change out, which this is a simple swap. Well, unfortunately this video is getting long and I'm almost out of time. I'm going to go out and press in this bearing, and in the meantime I hope to see you back here for part 3. Thanks for watching.